What? Just the man behind the man.
All right. So talk us through your answers here for number 1 and number 5. And again, good ideas to do things like jot it down on your page to refer back to the website.
So the equation we have is EK, which is motion, and it's mass divided by 2 times the velocity squared.
Why is that the thing to do with this problem?
What was the problem?
I don't remember. What was this problem?
Let me go.
The sheet's on the computer, just slide it over. Problem 1.
Because you're looking for kinetic energy.
Okay. So Yusuf, what are we gonna do?
So you have the mass, which is 2,000 divided by 2, and then we would have to convert 70 miles per hour into meters per hour, meters per second, and then we would square that, and then the answer would be
979,064 for kinetic energy. And then, yeah.
All right. Did it look like you had agreement from other groups?
Yeah.
And
Yeah,
then
we all
what
got
do
the
you need
same.
to add to yours to put the cherry on top?
Units.
Yeah.
What is it? What's the unit?
NM.
NM? Let's do NM. I'm just doing NM. Oh no. How do you erase?
So the butt that's closest to the tip of the pin will erase.
That didn't erase. Whatever.
It's a kilogram meters per second.
Well,
There we go. That was.
that works.
Divided Newton by meters.
Yeah.
That doesn't sound very common.
No, I don't know. I just copied them.
Because you took kilograms times meters per second.
Whoa, look at them scribbles.
Yeah, that's what happened.
You took kilograms times meters per second.
Yeah.
Yeah.
Isn't that right?
It is right.
No, it is.
Oh, it is? Okay. Did you take kilograms times meters per second?
Yeah.
Mm-hmm.
Yeah.
What'd you do in the equation? Whatever you did in the equation, do the same thing you do.
What number is it?
1.
Did you take mass times velocity?
Mass times velocity squared.
So what do you need to do the units for velocity?
Square them.
Yeah.
Maybe we're
Oh, you
Twitter.
just square them.
Did we say
Square them.
Ooh, I like that.
Squared. They're both squared. So meter squared over second squared. So what?
How to do this.
Wouldn't it just be right? Here.
Look, see that?
That's not erasing.
Hold
Just keep doing it.
There you go.
In that scribble.
Yeah, I like right here.
Squared per second.
Yeah.
Yeah.
Yeah, okay. Can we go to number 5 now?
Which is equivalent to Newton's meters.
Yeah.
All right.
All
I'm
right, cool.
talking the difference between a 2 and a 3 here, friends. Make sure we get the right units on things tomorrow. The easiest way to do that right is just do the same math to the units that you do to the numbers, and you can't go wrong. All right.
That is equivalent to Newton meters.
Yes.
Okay, cool. Number 5.
What else you got for us?
Number 5 was this cart, you know? It was moving and it got stopped by a spring. So we got 3 bars of motion and 1 of gravity, which doesn't really matter, but there was a spring, the cart, in the earth, and then the spring stopped it. So there's still that 1 gravity, but now those 3 from motion went to elastic energy. And that's shown down here in the equation.
Okay. And then rest of the room, I've got a little pear deck going for you over here. So if you want to hop in on
Where's the eraser?
kangaroos keep warm X-rays.
Just on the left side.
I hope so.
So
We got some questions for these
I
guys.
don't know. I guess I'm freaking lazy on that.
You have your eraser. I just want to know which one. There's only one button. Or am I missing a button?
Room?
There's usually a button, right?
What do you mean?
Look. Oh, that's how you do it, dude. Oh, check it out. All right.
Hey.
It's really small, though.
Can you make that K a KG? There you go. Still gonna be scripts.
Cool.
And so what they have up there for you is the qualitative conservation of energy problem or equation. And then I'm hanging back here to see if you got any other questions for them. And the question for you seems to be, why is there EG?
Doesn't it just like not matter? It's the same thing with and without it.
You are quieter than Peyton Brady.
I said, does it matter? Because it's.
What do you mean?
I mean, we could just take away the gravity and it would just like cancel each other out.
Would it change your problem at all?
No,
Okay. Would it make your problem simpler?
I guess.
Okay. So we could, if only we could find the white pen, but erasing is tough enough, so don't worry about that.
Yeah.
So you have it, but it's not changing. Because why is it not changing?
Because it's just the gravity stays the same the whole time.
Things not going up or down.
Yeah.
Yeah. Okay. So we could simplify it and say EKA equals ELB. And then the other question here is, how did you do 5C? What's going on in 5C? 5C wants to know the speed of the cart prior to the impact of the spring.
0.03.
Yeah, I don't know. I guess we didn't do that. Yeah. Probably look at this board to look at it though.
So what did they do over there? 'Cause it's related to the equation that you wrote.
Wake up.
I don't know.
I'm going to fail.
Well, what is EL going to be?
Plastic.
Oh, you said.
So why don't you guys take a moment to gander at that, see if you agree with what's on there, and see if you can figure out why they did what they did.
What's the equation for EL?
And we'll do the same out here.
Yeah, but what's the equation?
So the thing common to both Lol charts there, as you can see, for Yusuf's group, they've got 3 blocks of EK that becomes 3 blocks of EL. For the other group here that we're looking at, they have 2 blocks of EK that becomes 2 blocks of EL. It doesn't really matter the number of blocks. What matters is that the energy that was stored in the motion is eventually stored in the spring. How are they getting the energy stored in the spring here? What did they end up doing? This is where you might want the sheet handy, I guess, or I can
Yeah.
try to dig in the sheet back here, I don't know how. You know?
No,
Yeah, I
it shouldn't
can't.
be because this is the major access and it's only 10.
It's not too small if you got green.
No.
She's fine.
So a moving cart collides with the spring, and stopping the cart, the spring is compressed 30 centimeters. So what do they do with all that stuff?
They put it into the elasticity equation.
Okay? And And that tells us that E is 1/2 K delta X squared.
Yeah.
Okay, so also in the problem, it tells us 50 newtons per meter is the constant for the spring. That's in the image here. So 1/2 of 50, so 25 times 0.3 squared. 25 times 0.09. And what does that give them then?
You get 2.25 Newton meters.
Okay, can you go ahead and add a label to that for us?
Yes, sir.
Now you're saying one thing, but you're writing a different thing.
Oh, well, that's what they got down here. Think.
Square.
Is it squared? And here it isn't.
You get that button to work.
What do you want me to do?
So erase the newtons per meter because that's not what it is.
Okay.
If you look at they have the units in the problem. You just write out what the units are in the problem. It looks like they're taking newtons over meters.
Yeah.
And what's that getting multiplied by? You can use that big space above. This guy's in blank space.
Why is he screaming?
Being multiplied by meter squared. Do you want to take over, Yusuf? You can take over.
It's 50 times that.
Does he to do a squared plus b squared equals c squared?
A squared minus b squared equals c squared.
So it's just
this is a, right?
it's just Newton meters.
That's b.
I think it's always the bigger one.
Oh yeah, that's right.
Right?
Why is that right?
Because it's Newton over meters times meter squared.
Got it, kid.
I think so.
Okay. So if you look in the work there, you see newtons over meters,
Okay.
but then that other thing is getting squared, so that's meters squared. So newtons over meters times meters times meters, that shakes out to be newton meters. All right, cool. So that's the energy stored in the spring in the end. Where'd they go with that?
Then
We're kind of having to work the problem backwards. So this is the energy that ends up stored in the spring. Where was it at the beginning of the problem? It's stored where?
in motion. So they put it in the motion equation.
Cool.
Yeah.
So 2.25 newton meters equals 8 kilograms divided by 2 times v squared.
Yeah.
They get in the end.
They get that V equals 0.5625.
And help them out here. What does that need to be look like?
Here's the same thing. What? What has to be labeled with?
So this is where it's helpful to look at that big unit that they had to write on their problem, kilogram meter squared per second squared. If you take newton meters, which is kilogram meter squared per second squared, divide it by the mass, or half the mass, as it were, what's going to happen to that unit? So that's the 4 I'm seeing in the denominator there, right? It's the result of 8 kilograms divided by 2. That's 4 kilograms. So if you take newton meters and divide it by 4 kilograms, that's taking kilogram meter squared per second squared dividing by kilograms. What's that going to leave for a unit?
Nice meters per second since we're looking for
Is it? Is it just meters per second?
Yes, sir.
Alright.
So it was v squared, and then when you take the square root of it, that would leave you with meters per second. So go ahead and stop meters per second on there if you would.
They have it really small right here, but
All right. So then next up, whoa. Next up, that leaves us red or periwinkle. So go ahead and slide it down and whichever one you want to have to go next. Red or periwinkle.
I get a pick?
Your pick.
Red.
Red, come on up, Red.
We didn't, but we were like,
Red's gonna talk about number 2 and number 6.
We were number 1.
so they were talking about all the time.
Yeah, for like 20 minutes. Because they were so long.
They were so wrong. They should have just had us covered if we had one.
Oh, wow, Taylor.
I mean, let's go red.
Wait.
My hands are fucking cold.
Yeah, you said club swimmer.
Hell yeah.
Represent. Hey, who was right?
What?
Who was right?
I don't know.
You don't know.
I didn't like the energy game.
You didn't
Is that
know.
what you're talking about?
Yeah.
I didn't like what time it was.
Did it seem like it was like 10 minutes?
Maybe a little less than that.
Alright, crew, what's going on with you?
Maggie was swimming.
So a bungee cord stretches 25 meters and has a spring constant of 140 newtons per meter. How much energy is stored in the bungee? So we use the equation for EE, and so we said 1/2, and the spring constant is 140 times 25 for the change in x, because it stretches 25 meters, and we squared that to get 43,750 newton meters.
Spring, so 1/2 cat.
What is this called?
Alright, cool. Any questions on that? Can you zoom in?
It's 2 to 3.
Well, over. Alright. So, based on what you're seeing now that it's zoomed in, do you have any questions for me? Take a look at problem 2 and see if you have any questions. Come on, Fred.
Squared plus 1 squared is 4. And then you divide everything by 4 and y should be equal to 2. I don't have any choice. If d squared plus 2e equal to 2.
There we go. A question for you here, why is there no friction in B?
What?
Why is there no friction?
I can't remember my password to my non-teacher Gmail account because I'm trying to incognito use to sign into this here deck, so I'll just ask my questions. What are the units on the spring constant?
They're newtons per meter.
Oh,
What is six?
alright. So then on to question 6 for us, if you would.
So a rock is shot straight up into the air with a slingshot that had been stretched 0.3 meters. Assume no air resistance. So we had the EE3 blocks. And then in the system, it was the rock, the slingshot, and the earth. And then so when the rock is at the top with no velocity, it's all EG. So we had it the same amount of blocks as the beginning. So E at A equals EG at B. And then what we did to determine the greatest height the rock could reach, we found the E at A because we were given the constant. So we got 4.5, and because the E at A equals EG at B, we could say the EG is 4.5. And then we used the EG formula, M times G times change in height, and to get that the change in height would be 0.9 meters.
Any questions about any of that? Again, there's a quiz coming tomorrow. There might be stuff like that. If you're not 100% on why they did something, now's the time to ask quietly if
Your
you're
mom will be here.
get yourself sorted out. No question too low level right now.
I'm not even skipping. No, I'm in Chicago.
Set this up so somebody can turn this into a proposal for partners. That'd be romantic, but it's happening. Oh, sorry.
Are you going to Florida? Really? No, I'm in Chicago.
Alright, nobody's got questions. I guess we're good to go. Cool.
Okay.
Let's slide on down. And what do we have? We got 3 options to choose from. Turquoise or sunburn. What's your favorite?
Yes.
Sunburn.
Sunburn. Come on up, sunburn.
Yes.
When did you start eating?
Let's do it. Chase, nice job, Chase.
Yeah.
Contemplating the starting position. Usually up to 6.
Patrick Donnelly did?
I would say that.
That's funny.
But some not true.
He's friends with like
German warfare.
Yeah, Patrick.
Now you got the stock 6 too. Now it's going to spread.
He came into an interview and just got hired.
My anniversary. How am I going to go to Big Girl?
Yeah.
Oh,
Really?
Dude,
Dude.
Plus, it's gonna be Mother's Day.
I guess not.
Too much. Too much. Problem 3. What's going on there again?
Only a sophomore. So what did you get?
how fast does a 50-gram air need to travel to have 40 Newton meters of kinetic energy? So we transferred 50 grams to 0.05 kilograms. And then we did EK equals 1/2 mass times velocity squared. So we did 40 Newton meters equals 1/2 times the mass, which is 0.05 kilograms, times v squared. And then we solved for v and got 40 meters per second.
All right, take a moment to ponder what they have up there. See if you have any questions for them. There's just some slight stuff. It's kind of like paying attention stuff.
So here's something.
Talking about something.
Where we Math. That was another.
We should take a trip to Texas.
We should. That's actually fun. I need some food from pants.
Just show them both.
Yes, do it on Wednesday.
Okay.
Is Carter looking? Carter and Ben looking good.
I'm not in the end.
All right, so a couple of questions on units. What are the units
Ben
on the
was the
1600 and what are the units on the 40?
Meters per second.
Then newtons per meter.
And then if we go back to the sheet, what about the 40? What should that be? See the difference in what's on the paper and what you have there?
Newton times meter.
Can you change that real quick with the pen?
Yeah.
It's tough because we have the one thing, both things involve newtons and meters. Spring constants are newtons per meter, but then if we're talking about injury,
There's like
that should be newton meters. Can you like just kind of like maybe scratch that right above that?
yeah.
All right, so 40 newton meters.
Are you gonna pet my dogs when I come in? Okay.
And then this question about the units on the 1600.
Velocity says in meters per second.
Is it equal to velocity?
Velocity squared.
So what would the units for velocity squared be? That'd be velocity times velocity.
So meters squared per second squared.
Yeah, go ahead. Get that there.
So double base.
So velocity squared is 1600 meters squared per second squared. And then what'd you do to get that last line?
We took the square root of both sides.
Okay, so what would your answer to that be?
40 meters per second.
So there's a button.
I think the hold button.
Yep, there you go. Yeah.
Ah.
Alright, cool. And again, the reason that's happening is we think back to that unit, newton meters, and my gosh, maybe write that down in your sheet because that's come up with almost every group. Newtons times meters is kilograms times meters squared over second squared. So when they divided it by the kilogram, right, they had 1/2 0.05 kilograms, divided both sides by that. That gets the kilograms out of there. That left the meters squared per second squared, and then they took the square root of it, 40 meters per second. All right, cool. Go ahead and talk to us about problem 7 real quick. Roll.
Probably make this one good, right?
Roll real quick.
So for position A, we have e.g. 3 things. I don't know, 3 boxes, cubes, whatever. And then for position B, we had 2 for EK, and we did a half for both EG and ET. And then, to be honest, we weren't sure what to do from there.
So
To find
based
the-
on what you have in your Lol diagram, can you write a equation for this thing? How is the energy stored in part A?
Nice.
So EGA equals
Yep. Like that.
EKB plus EGB plus ETB.
Whoa, hold up.
Okay, so can you read out what you have there quick so people can ask questions if they have them? Or big in it? Change the amount. There you go. Thank you.
but I wanted to stay here longer.
Live there. We'll see you tomorrow. Work on those problems on your own for practice. This will be